In this video, we shall look at impedance in AC circuits. Let's assume we have a following AC circuit. So that is the AC source. You have a resistor, an inductor, and finally a capacitor. Like that. They are connected in series. So this is R, this is L, inductor, and this is a capacitor. This is an AC source. We can label the current in the circuit like that, understanding that the direction of the current will always flip because of the nature of the circuit, namely, we are dealing with an AC circuit. So let's assume the electric current is represented by the cosine function, like that. If that is the case, the voltage across the resistor can be written in the following manner: cosine omega t. This is the amplitude of the voltage across the resistor. And we know the voltage across the resistor and the electric current are always in phase. The voltage across the inductor leads the electric current by 90 degrees. So its expression will assume the following form: cosine omega t plus 90 degrees. Capital VL is the voltage amplitude across the inductor. The voltage across the capacitor lags the electric current by 90 degrees. So its expression would be V sub C, where V sub C is the amplitude of the voltage across the capacitor, cosine omega t minus 90 degrees. We can write the capital V's in terms of electric current amplitude as follows. V sub R is the electric current amplitude times the resistance of the resistor. V sub L is the electric current amplitude times the inductive reactance of that inductor. And V sub C is the current amplitude times the capacitive reactance of the capacitor, where we know X sub L is omega L and X sub C is 1 over omega C, where C is the capacitance of the capacitor, L is the inductance of that inductor. Let's sketch phasor diagram for the circuit. Now we know the voltage across the resistor can be represented by a phasor like that. And since it is in phase with the electric current can be also drawn on top of that resistor voltage phasor. So this is capital I, amplitude of the current, and this is V sub R, the voltage amplitude across the resistor. For the inductor, the phasor is like that, so that is V sub L. And for the capacitor, it's going to go like that, V sub C. So the voltage across the inductor leads the current by 90 degrees, and voltage across the capacitor lags the current by 90 degrees. Let's assume V sub L is greater than V sub C. Then we can sum these two vectors and represent another vector like that on top of V sub L and call this vector VL minus VC. Vector summing this vector and that vector would give you the resultant vector, which we can call capital V, which represents the voltage across that alternating source itself. So this capital V is the amplitude of that voltage produced by that AC source. And in terms of capital I, it is written as I times Z. Z is what we call the impedance of that circuit. And the angle between the voltage amplitude of the source and the electric current amplitude is called the phase angle. From the diagram, we see clearly that V is quite simply the square root of VL minus VC squared plus VR squared. In other words, I times impedance equals the square root of I times XL minus I times XC squared plus I squared R squared. When you cancel the i's from both sides, we end up with an expression for the impedance in terms of reactance and resistance. So it's namely XL minus XC squared plus R squared. And you see impedance is a quantity that is quantified in the units of ohms, just like reactance and resistance. And from trigonometry, we see that the tangent of that phase angle is quite simply this length over that length, which is I times XL minus XC over resistance times I. So I cancels, leaving you with this expression that enables us to calculate the phase angle of this AC circuit. What if VL is less than VC? Then we can vector sum VL and VC and end up with a vector VC minus VL as shown here. So the vector sum of this vector and that vector would give us a vector like that, and that represents the amplitude of that voltage source, and it can be written as I times the impedance. So this is the same as that length, and the phase angle now is defined like that. And in this case, you can clearly see that this vector V lies on the opposite side of that current vector, and this voltage clearly lags the current. And since the reactance of this circuit is defined like that, and this represents a negative quantity, tangent of that phase angle will also be negative, and for this case the phase angle lies between 0 to minus 90 degrees. The expression for the impedance, however, is the same as before, namely the resistance squared plus X squared, where X is the reactance of the circuit, namely the reactance of the inductor minus the reactance of the capacitor, and you square root this entire sum. So in summary, impedance of an AC circuit plays the same role as a resistance in a DC circuit. However, impedance is actually a function of R, the inductance of the inductor, the capacitance of the capacitor, as well as of the angular frequency of that source. Let's look at a problem. A series AC circuit contains the following components. The resistance is 160 ohms, inductance is 280 millihenry, capacitance is 2.5 microfarad, and a source with the source amplitude, the voltage amplitude, is 210 volts, operating at 50 Hz. Calculate the inductive reactance, capacitive reactance, impedance, maximum current, and the phase angle between the current and the source voltage. So let's do part A, inductive reactance. So that is X sub L, and it is given as omega times inductance. Omega is 2 pi frequency in Hertz times inductance. So 2 pi frequency is 50 Hertz, so times 50, and the inductance is 280 millihenry, so times 10 to the power minus 3 to convert that to a henry, and you're going to get about 88 ohms. Part B, X sub C, which is the capacitive reactance, and that is given as 1 over omega C. So 1 over 2 pi 50, 50 is the frequency in Hertz. Capacitance is 2.5 microfarad, so micro is 10 to the power minus 6 in order to convert that into farad, and you're going to get about 1,273 ohms. Part C, impedance. Impedance can be determined by the following formula, R squared, where R is the resistance 160 ohms that we are given, times XL minus XC squared, and that's going to be about 1,196 ohms. Part D, maximum current. We know the voltage amplitude, which in this case given as delta V max equals the maximum current times impedance. So since we know this, we know that we can determine the maximum current. It is given as 210 volts, which is that number, over 1,196 ohms. And the answer will be in ampere, which will be 0.176 ampere. And finally, the phase angle. Note that XL is less than XC. So according to our previous discussion, the phase angle must be a negative number. Tangent of that phase angle is given by X sub L minus X sub C over the resistance. So X sub L is 88, X sub C is 1,273, resistance is 160 ohms, and you can find the phase angle. And it will turn out to be minus 82.3 degrees, as we have expected. And that solves the problem. Thank you for watching.